Hello and welcome back. Today we are going to talk about another system design use case that's called social messaging chat service. So we can say, for example, Slack, WhatsApp, WeChat, and also the Facebook Messenger. These are some of the chat services available in the social media itself. We'll talk more about the system itself. Before that, I would request, like, if you haven't done yet, please subscribe the channel and press the bell icon to get more updates in the future. So let's get into detail for the requirement. What are the different requirements it could be to design any of the kind of a social messaging chat service? Let's talk about the functional requirements. The functional requirements would be there should be a capability of chatting between one-to-one and as a group chat, right? And the second one would be like users should able to send text as well as some multimedia files like videos, photos, and document files, something like that, right? And the third one would be like there should be a chat history, in the sense like if someone is opening the chat today, so he or she should able to see the chat with that particular person trying to chat with, should be all the history from day one. Okay, so unless there is a setting to setting to clean up the history from a particular before some particular retention time period. So and the other one is there should be a feature to which really talks about like if the user is online or offline at a particular specific time, right? And the fifth one would be like there should be a status available in the application where it talks about if a message has been delivered or read or sent to the recipient, right? So the status should be there. So these are the functionalities we are going to talk about, and we are going to design the system for these. There might be many other features can be added to the system. However, at this point we'll touch upon these are the functional areas we are going to talk about. Alongside, so if you see like what would be the non-functional requirements. So if we say non-functional requirements, there should be the service should be scalable enough to whenever we add more users to the system, and there are more and more users of that particular service increase by time, the system should be scalable enough to deal with those high number of users. Then it should be consistent in the sense like whatever the service we are going to build or the system we are going to build, the service should have the capability to deliver the message or send the message, read the message consistently, in the sense like there should be consistent. If a user A send one message called M1, so the M2 should be, the time stamp should be after the M1, right? So M1 must be read or must be sent before the M2 set the send status. That we can say like consistent, right? So and the high availability, in the sense like if anytime server goes down or the backend failure happens, then it should be a resilience, kick off the server as soon as possible, or there should be some other way to deal with the request which is fail in one server. There should be other servers to really take the ownership of that particular request to response to the user. So these are the requirements, functional and non-functional. We'll walk through the whole session on top of these requirements only, right? So let's get into how any chat service works, right? What is the functionality behind the scene? So for any chat service, so there is very fundamental use case, right? So that there is a sender which sends the message to a receiver, right? So in between there should be a server. It usually receives the message sent by the sender, and it processes something and sends that to the receiver, right? So once it sends to the receiver, it gets one acknowledgement, right? Okay, the message is received by the receiver, and one acknowledgement also come to the sender, like, okay, the message has been received. So this is very fundamental workflow of a chat service, right? So if so how many users would be there in a chat service? Maybe it cannot be one, right? It has to be more than one, either two or more, right? So one can send a message to another person, or one user can send message to a group of people, right? So that's where it called one to one, or one to many, okay, or many to many, right? So that can be the scenario where the message can be sent, right? So this is a broader idea, broader workflow, like how a chat service works, like a message from one end to another end. If we go with the high level design, how it would be, like the user, okay, so message sent, okay, like message, and then that message message goes through some service, and there are one or multiple server, you can say, right? And then there should be something which stores those messages somewhere, that called the some database system, okay. It may be SQL or NO-SQL, we'll talk about that. But this is the overall high level design, how it all works. Like, it's the sender, it can be a receiver also, right? Let's talk about deep level the system design, and how we can design the whole system in a scalable manner. In this whole system design, what we are going to do is, we are probably going to use most of the essential components available for the system design that we have already discussed in our different previous sessions, and those related videos are also available in the channel, and somewhere in the playlist. You can go through that and try to understand, like, what are the really those components are really do, and what are the meaning of those components, and how they can be used in different scenarios. When you talk about the scale, so probably the scale we are going to talk about is the total user for that service is all about 2 billions, and the active users would be 1 billion, right? And the total messages it's going to the server in and out for day is 10 billion, right? So this is the scale we are trying to cope up with, and keeping those numbers in mind, we'll try to design the whole system, right? So if you see here, we have the user or client, whatever you can say this is, and then we have one component we are going to use is load balancer, and why we are going to use, we'll definitely talk about that. Along with that, we are going to use API gateway. Why we are going to use API gateway is, like, we have to use some of the APIs as well to deal with some of the external functionalities out of the messaging service itself. For that, we are going to use API gateway to really handle those API calls to the system, right? And the other component is going to use one microservice, probably, maybe that's called as message processor, right? Why we need this kind of service itself is, maybe whenever we are client sending any message to the system, so that message might have some limited attributes, okay, what the cost the client is needed, but there is something the server want to add some more attributes to the message before storing that particular message into the database. For that, we probably going to use one of the microservice which will take care of that, processing the message and adding some new attributes to that. We'll talk about that, what could be the more other attributes it can be added to the message while it's storing, right? So the server is the actual server which really creates the connection between the client or user to the chat service, right? So why it's written like session manager? So probably every user, they're trying to chat with someone else or some other group. So every time there is a chat initiation, so there will be a session will be created for that, right? So in that case, there has to be multiple sessions for multiple users for multiple chat communications, right? So for that, there has to be a session manager which will manage the whole number of sessions being created in the server. So and then we are going to use the database. So it can be SQL database or NO-SQL database, that doesn't matter, but we have to store the detail of the message and chat detail into the database itself, right? So then the cache we are going to use, what exactly the cache doing. So again, I'm saying there is a related video also available in the channel, so you can go through that and walk through that, what exactly the cache is, why we use that. So cache is normally we are using when we are trying to make the service performant, and we don't want to make multiple trips to the database because the database trip is always costly when we talk about the performance and the latency. So that's why we will put some of the data which is very frequently used into the cache, and then the server will directly talk to the cache instead of going back and forth to the database. And along with that, we are going to use another component called message queue. So the message queue is one of the component which is being used heavily in any system design at scale. So this component is being used when actual servers, right, backend servers are really taking a long time to process the data or deal with the data. Then usually we used to use the message queue to really put the messages into the queue so that it can be processed at a later point of time. So these are the very minimum components for this system design we are going to use. Let's connect the dots, right? Let's, for example, when any user or any client sends the message to the system or trying to chat with someone else. So what it does is the request goes through a load balancer. Why we are putting the load balancer here? When we are saying like there are billions of users, active users, there are number of messages very frequent, right? So in that case, if you will not put the load balancer here, then this API gateway or whatever the service we are going to use, it will be super overloaded, right? And they might not able to complete the whole process in time, and there are a lot of blockage of the whole system, and the system might fail or might take long time to process, and by the time user might not have patience to get those replies and chat with each other. It will not a real time, right? So for that we have to have the load balancer so that it will really take care of the request and split the request through different servers available in the behind the load balancer, right, for actual data processing or the message processing, right? So once the request comes through the load balancer will decide like where to send the request, and it will then go through the API gateway, right? Or it will go through the API gateway, and what it will do, it will try to send a request to the server to initiate a session, right? Initiate a session. So the API, the moment any user opens the WhatsApp or the messaging system, so and try to chat, so immediately it will send a request to the server to initiate a session, so that a session will be created for that particular user for that particular time duration, whatever the time duration yes you want to try to chat with the other person, right? So once the initiation request will go to the server will immediately there is a session manager, it will create a session over here, right? Immediately a session will be created, and a notification and an acknowledgement will go to the user itself, right? The user device, right? So so now whenever it will create a acknowledgement, send an acknowledgement like a session has been created, then the user is ready to chat with, right? So so now we'll talk about like when it's goes a particular request goes through for the initiation, then what are the different different attributes going through that particular request. We'll talk about that. So I'm trying to cover first the whole flow, like how the whole chat system flows, and then we'll talk about small details for every component, right? So now if you see like the acknowledgement record, the user is now ready to chat with the other person, then the chat session opens, right? The chat session is open now. So instead of so what it will do, it will create a session. Okay, so session is created. Now the user starts chatting, sending the message, and message getting through this server. Now whenever server really gets that message gets that message get through this microservice to process the message, and then from these once the message has been processed, then the server again gets the process message and send it to the database, right? So once the database is able, the message is available in the database, then the same thing will be loaded into the cache, right? The cache service. Then the next time, anytime user want to read the history, the same thing is always available. So if the user when scrolls up, so it want to see the history, right? So at the time of the history, so what it will do, the anytime it request come to see the request, the same request goes through the same flow, and it goes to the server goes to the cache instead of going back to the DB to get the history, right? So that is the biggest benefit of the cache we are going to use because of to lower the latency and increase the performance, right? So that's where it will be correct. So now let's go into a little bit deeper into what exactly the message contains and how the message getting stored, right? So before that, so you missed to talk about that message queue, right? So what exactly the message queue will do here, right? Now let's, for example, we have we have the servers sessions, they're trying to process their data, but what if a particular session has some issue and it's not able to process the whole the message and to store into DB, right? So what it can do, it process the data, okay, process data, and before storing the DB, it can store these into the queue itself, right? In the queue itself, and from that queue, whenever it will clear the whole queue, or by processing the all messages, then it will keep processing one by one from queue and send it to DB, right? So that means, so if there is any, due to any region, there is a blockage in between the server and the DB, then it will immediately send that message to the message queue, and then whenever it will find the room, it will try to get the data, get the message from the message queue and process, send it to the DB, and same time it will also do the same thing for the cache as well, right? So the message queue will do the same way. So now we can see in a different lens, right? So this is for a server. What happens if there is a blockage happen somewhere around here, right? While sending the message itself, right? Before sending the message, while it's sending the message, right? Message, what happens if the blockage happens at this point only, right? This point only. So immediately what it can do, it can be, the message can be routed to this message can be routed to here, right? So in this case, what you'll do, so the actual message, the message has not been processed yet, that will go through the message itself, message queue, and then whenever it will the blockage will go away, then the server will actually read this message from here, and then process it, and then store it to here or here. right? So this is how the message queue can help in whole system design. So that's a biggest benefit for the whole system while we are designing a system at scale, right? We are talking about the hyperscale, and we are talking about billions of users and multi-billions of the message we are going to going to send or receive, and we are trying to manage billions of sessions as well, right? So these are the components we always need to think of while designing the whole system at scale, right? So now let's talk a little more about like what actually message it happens and goes through, and what are the details it getting sent to the database to store, right? So to understand that, there might be two or three things we can need to think of, right? So the first thing is like the contacts, and the other thing is like auth, right? Authorization. And the third thing is like consistency, the uniqueness. So these are the things has to be taken into consideration. So that's why when we are talking about the contacts, so without contacts, any user or any system cannot be connected to the other person to chat with, right? There has to be a contact somewhere, right? So once any user installs the chat service, that client itself, so the immediately it might try to access the contact itself, and from the contact, so whenever any user try to use any chat service, so there should be a contact table, right? Contacts table has to be stored here, right? In the contacts table, there might be the contact ID and the contact number, right? Contact number, and maybe created on something like that, right? So this will be contact table. And once contact is done, so whenever it's trying to send any message, so this API gateway comes into picture to get the contact detail from the contacts table itself, right? And do the further message communications, right? So now once contact is there, to send any message to any other group or any other person, you have to have authorized to do so, right? So then that authorization API comes into picture. These are the APIs we can talk about, like there should be a contact API, authorization API, and to create a unique ID of the any message we can run. But this is not very important here, because the service itself can create that. But yeah, the API we can have to create the uniqueness of a message, right? So now any message goes into that, what actually a message contains, right? What can a message contain? The message can contain one message ID. So whenever any client or user sends any message, the message may have minimum these are the minimum attributes a message might have, right? So it can have a message ID, and it should have a message which is actually getting sent to the user. So that should be encrypted, okay? When we are saying end-to-end encryption, right? So the message should be encrypted from the source itself, and throughout the message transition. So whenever it's getting into the stored into the database, also it has to store with the encrypted way, right? So there should be message which is already encrypted, and it goes along with the user ID, whoever the user is sending the message, and the device ID and the timestamp, and along with the important attribute is the receiver, right? The receiver ID, or maybe you can say the session ID that you already got from the server when you have initiated a session. The client already got the session ID, right? Session ID arc, right? So the session ID got from the server. So it will for every message the session ID will go through that with every message, right? So these are the minimum attributes. It has to be there in every message, so that every message can be identified uniquely in throughout the transition of the message from the client to the data store, and the data store to the receiver itself, right? So these are the things, and also when you see like these attributes will helpful when we'll talk about like the status of the message, right? The status, message has been sent and has been delivered or has been read or not, right? So those status also, when we are talking about those status, so these are the attributes it will come into picture when we are really trying to visualize those requirements, right? So these are the minimum attributes. It has to be in every message. So the message is coming from here, right? Message is coming from the user. So once message is going through this gateway and this, it goes all the way the server, right? So now server identified all these attributes from the message, right? But it doesn't have any idea like if we want to what is the encrypted key, right? So there is, the server never got the encrypted key from this particular message, right? For every message, server is not getting any encrypted key, right? But the message is encrypted. So then how the client will decrypt the data, right? So once it's sending, it's encrypting. While it's trying to see the history, then the history has to be come from the database previously stored. Maybe it's 1 year back message or 2 year back message, right? So it has to come from the DB. It cannot be stored in the client, right? So if if we are talking about the any WhatsApp client or any messaging client, then we might we could go through the whole detail of the client, how it's storing the message and its cache and all. But we are talking about the server side of the house. So client will only, we can say like client might hold 1 day's message or 2 days message. Maybe it can be 1 month older message, but cannot be years and years message, right? Because it will too much load for the client and also the device it's being used, right? So when it's trying to show the look into the history, so it's to go back to the DB and the system has to show the previous message. So when it comes from DB to the system, so it has to the client has to know about the encryption key, right? Otherwise it cannot be decrypted, or it can actually read the message, right? So once that will be done, then what it will do, so whenever the server gets the message, so it sends the message to the message processor. So that what message processor does is, message processor adds the encryption key to the actual original message, okay? And here when it comes to this, it message plus the E key, right? The encryption key, and then it goes to this. So we can say here message, it comes with message, but it gets message with E key, right? Encryption key. So whatever the data process, maybe it adds encryption key and it process some of the other things behind the scene. Maybe you could write some other functionalities when you are processing the message, or while you are processing the message, you might want to send some of the signals to other system to do other things. Then you can do that here as well, because you don't want to put the whole load on the session manager itself, right? So once server process the message and get the process message, and then it will send the message to the DB. So now when it sends to the DB, so there will be ongoing catalog, right? You can say like message ID, right? Message, maybe you can say some unique ID, then in the message ID. So whatever the attributes you are getting, there might be a table it getting stored, right? So the message ID, encrypted message, right? message, and you can say like this is message table, right? So message table may have the message ID, the actual message in the encrypted message, and the user ID, or you can say like the user ID or sender ID, right? Sender ID and the receiver ID, and the device ID, and then the session ID. Most important, right? Session ID. Otherwise, one message can get into the other group or the other person, so it will be a conflict, right? So that's what it is, and the timestamp. So we'll talk about more detail into that when we're talking about another part of this particular design. But it could be the message table. Actual message table could hold all these things, right? And along with that, it has to have a encryption key, N key, right? So what it got from the message process message, right? So this will be the message detail. It has to be, right? So now once the message is available in the DB, so immediately what it will do, it will also load that message into the cache, right? The cache, so that anytime it will be always the server will always read from the cache rather than reading from the DB, right? So this is what it can be, right? So now the message is stored in the database, correct? So once that is stored, so the session ID already there, and there is a sender ID also available here, right? So now what it will do, the server will immediately store the message into the data store and send that message to the receiver itself, right? Maybe this guy is the receiver, and the same message will go through this, it will come through this, okay? So this will get the data from the message from the server to the sender's device, right? So immediately, so now you might ask like why we are storing the message immediately to the DB before sending to the message. So yes, that's because why? Because like what if the message sending failed to the receiver, right? So anytime if we have stored the message before sending that to the receiver, anytime the sending fails, it immediately retry with the stored message itself, right? Or anytime something mishappened to the device of that particular receiver user, then that message cannot be sent, right? It neither be delivered, neither be sent, or neither be read, right? So in this case, what it will do, the message is already available in the DB, so anytime it can retry whenever the user will come online. We'll talk about like when the user is online or offline, how the message will be deal with that, right? So this is the overall message transition it can be, right? And how it will happen when any message goes through that. If we are going to talk about the status, right? The status of a message. So if it has sent, or if it has not been sent, or it's delivered or not, or it's read or not, right? So those status usually have that blue tick, right? So okay, so I don't have blue, so I can just make it. So whenever any message sent, you usually get a single blue tick, right? Next to the message, just next to the message, you used to get a single blue tick, right? And when it's delivered, that means there is a double blue tick, right? So not blue tick, those are gray ticks, right? So when it's actually sent, it's a single gray tick, and when it's actually delivered to the receiver system, then it becomes two double gray tick, and when it's actually read by the user, read by the receiver, then it the both becomes the blue tick, right? So that's how it defines like if it's a sent, delivered, or read, right? Then how we can maintain this status, right? How it can be done, right? So before this, let's talk about like what if a user or a user device it went offline, right? So the sender sent the created the initiate the session and send the message, but the receiver end itself is the device is not on or not available offline, right? So in that case what it can be done is the message went there and message stored in the message system, the database system, and immediately there is a another table being maintained for the delivery system, right? Delivery system. So that can hold what exactly it can hold: the session ID, the message ID, and the status, right? Read, maybe sent, delivered, yeah, sent, delivered, and read, right? Read. So every message, whenever it's getting stored into the database, immediately there is a entry will go to this status table, right? So status table, so it will immediately give an entry to this table and then try to send the message to the receiver, right? So if receiver is online, then the receiver can the message can be sent to the receiver's device, and there is a status, maybe there is a status called true. For example, the message ID, session ID, message it, and the sent is true, right? Once sent is true, and this guy, the sender will get an acknowledgement called single tick, and then whenever the message is going to send to the receiver, then it will make a flag delivered is true. Okay, so if there is a offline, and whenever the user reads that message, and the read flag also becomes true. So when next time the same user try to send the message, and by the time the other end of the user, the receiver, is already went off offline, right? So what it will happen? See, there will be the same session ID, right? It's the same session ID, but message ID is different. Okay, because as we say, like every message has its own identity. So what message has been already sent out there, that will be there. When the next message it comes from the sender, and it goes through the whole process, then there is same session ID but a different message ID. It will come with the sent. Sent is true, right? Sent is true because it's the status is sent for the sender, but the deliver is false because the message has not been delivered yet, because the server saw like the receiver and the device is offline, right? It couldn't send, so the deliver status will be still off, right? Off, and the read also will be same off. Only unless you are the message has not been delivered, it cannot be read, right? So that's how it will be. Then the moment, so till the time the user message with that particular session, it will always hold the single tick mark with the gray tick mark, right? So when any time this particular user comes online, okay, so then the server knows like the user supposed to supposed to get the message is now online. What it will do, it will try to resend this particular message which is not has been delivered. It will try to deliver that message. Once that message delivered, so it might be possible like the user came online, okay, and it's trying to chat with someone else rather than the actual sender. Previously the person was chatting, right? So in that case, it will show that that particular message has been delivered, right? However, but at that time the sender will get 2 tick marks with gray, right? But the sender has not been read yet. So here it will do once delivered to the receiver end. So the server will update the status, the delivered status to true for the new message ID, right? So but still the read is false, off, right? So until unless the receiver is reading that particular message, right? So once that that receiver will come to that particular session or the chat window of that particular a specific sender, then that message being read, right? So when it's getting read, so the read itself is, and there is no control from the server, right? So it's completely client side. So now whatever the device this user is using, so that client will send a request, send acknowledgement to the server, like, okay, this is the message ID, this is the session ID, and this message had been read by the user, right? Then immediately what it will do this particular server, it will immediately update that particular record, the read to true, right? So now all the messages are sent, delivered, and read. So the moment it's updating this particular flag to true, read, then there is a acknowledgement comes from the server itself to the sender, like, okay, this is read, and they got a blue tick, right? That means that message again read, right? So this is how the status can be maintained, right? So now, how if we are going to keep storing this status in the database itself, then it's always a very high latency, and also it impacts the performance. So that also, mostly with these status tables, all these things we mostly hold in the cache system. So this cache system will take care of holding the whole status table to deal with the all messages it's happening in any of these sessions, right? So that server always deal with this rather than going back to the database, correct? So this is the whole scenario, how it happens when it comes to the to the status, maintaining the status of the message, correct? So when we are talking about all these, so there are some important points we are probably missing. What is that? So first thing is, like, while all this communication happens, so while all this message communication happens, so what kind of protocol we are going to use, or what we can leverage the protocol to really make the message robust, right? Message communication robust, correct? So for that, so we have HTTP, right? Okay, so the what kind of protocol we can use, right? Protocol. So we can use the HTTP, okay, and the most widely used protocol, being used in the WhatsApp service, if you say, like XMPP, right? So this is the extended messaging protocol. So being used by the this is the extended messaging protocol being used by the WhatsApp, and most of the I would say most of the chatting system to make the messaging communication robust, right? So while when we are trying to create a session between the client and the server, so we can make a HTTP, but the complete HTTP is one way, right? So it's a sender sends a request, okay, it's the receiver, and this is goes to the request, right? It's a request, and there is a response comes from the server, right? Acknowledgement, and it's done, right? The request itself is complete here. And whenever any new new message goes, then it probably goes with a new request, and the acknowledgement response, and it's also complete. So the life cycle of any request, it's immediately completes when a particular response got from the server, right? So in this case, what it will happen, so every time we are trying to send one message, we have to keep creating new request and sending that, and we have to wait for the response, right? So it's kind of a walkie-talkie, right? Once you have to send, you have to finish it fast, then the other end has to or talk, right? So otherwise it cannot be, it always a unidirectional, not the bidirectional, right? So to make a HTTP bidirectional, we have to add the handler to that, right? So that it will become a WebSocket, right? So now this is the HTTP way, right? So when the WebSocket comes into picture in WebSocket, so what it will happen, it will usually usually happens is from the sender from the sender, it goes to the server. For example, server, there is a goes request, HTTP request, and it gets a response and adds a handler. So once it adds the handler to the HTTP request, it's become the bidirectional now. Now the sender can send the message immediately. The server can same time send some some message to the sender as well. So it's a bidirectional. It's not necessarily once sender will send, then only receiver can receive that data, right? Sometimes you can the same the same protocol probably we are going to use, mechanism we are going to we might use in the chatting service, right? So what it will happen most of the time, you might have seen, like when you are chatting with someone else, so when you are typing, so the other person also typing, right? So in that case, anytime you are trying to send, the same time the other person also can send a message to you, right? So in that case, it's a bidirectional. At a particular time, both can send the message to each other, right? It's not necessarily if one person has to send, then only the other person can send, right? So that's not the case. So in the WebSocket, so that will happen the bidirectional, right? So this is the best way to create a channel to communicate between multiple persons, right? Or groups, right? And then the other thing is, so if you talk about the high level design, so this is what the high level design would be. There is a sender send the message, and there is one or multiple servers which receives those messages and then process that message and store that into DB. Some kind of database. It can be SQL or NO-SQL. We'll talk about that in a later point of time. So and then that once that message got processed, and then it will try to fetch some detail from the database as well, regarding the sender and all, and regarding the receiver as well, and sends that message to the receiver. It should be this way, correct? So this is very much high level design of the of any messaging service. It's very high level. Okay, we'll talk about very low level, like how we can pan out the whole system. So how can make it more scalable? So when we are talking about the so this can be, okay, whatever the high level design we have discussed just now, so it can be applicable for 1 or 10 or maybe some thousand of users, right? But it cannot be definitely scalable for multi-million or multi-billion users, right? So when we talk about that, we need to first estimate what are the how many number of users it can be, and how many messages can be come to the system, and how big the system would be, right? So at scale, correct? So when we talk about that, we have to talk about the estimation, right? The capacity estimation, right? So when we talk about capacity estimation, the first and foremost the point comes into the mind is, okay, how many expected users we can have for the chat service, right? So let's, for example, there are users 2 billion active users, and on an average we are getting the total number of messages per day, messages per say 10 billion. So that means, like, if there are 2 billion users, and we have active users 1 billion active users, then the messages we are getting for day is like 10 billion. So this is our expected volume of the message and the number of active users, right? So if that is the case, then we have to talk about, like, how much traffic it need, what is the traffic, and what is the bandwidth we need, and what is the storage we need, right? And it can be the disk, and it can be the memory. So these are the things we are going to we have to estimate, like how much resource we really need, right? So to definitely we'll not go through bit and pieces of this capacity estimation, because we already have discussed in a different a different video, a different session that is available in the playlist itself. So you can really go through that. If you have some clarification required, or some more you want to learn some more related to the capacity estimation, how you can easily do that, and keeping all these things in behind your mind. So you can go through that video, you can learn more about that, right? So but here we'll go straight forward the numbers and how much we really need, then we'll proceed further for the next set of regions, right? So when we talk about the traffic, so what we need, like as we know, like 1 day, 4 days, so every time everything we need to bring down into per second, right? So that it will be very easier to estimate everything, right? So let's think about, so in 1 day, in a day, there are 86,400 seconds, right? So if we think about that, then what will be that traffic per second, right? So there are 10 billion, okay, 10 billion messages, right? And divided by 86,400. So that will be the number of messages going to come to the system per second. Okay, the other thing is message handling. How can handle message? The message can be handled two ways. So one is push, other one is pull, right? So the push is nothing but the push notification, right? So that means, for example, the user is offline. So how can a user can know, like, okay, I got a new message? Can this be a push mechanism or pull mechanism? Because if it's a pull mechanism, then every time the client, the user has to open, in every second has to open the chat application, and has to see like if there is any message, right? Because the client has to keep pulling and keep checking with the server if there is a message for him or her, right? Then it will keep checking. It will be a continuous process. The moment any message comes for this particular user, then it will try to show that. So that means it's trying to clog the whole channel just for checking the status of the message, if there is any message available in that, right, in the server, right? So in this case, it's always costly, and user has to really keep opening the chat message to initiate the calls, right, to the server. So this is called the pull mechanism. So pull is always costly, and it's not a feasible solution for the message handling for any of the chat service, right? Rather, if we'll convert it to push, right, the push is something like server will push the message notification to the the chat user, whenever any message available in the server for him or her, right? So if someone send message, so the receiver don't have to really open the the receiver doesn't has to open the chatting service to really get the message detail, right? Even if there is the chat message chat application is not open, so the user can get a notification like you have a new message, okay, and from WhatsApp or a Facebook messaging or some wherever it can be a Slack or something like that, right? So that's called push. That means we are minimizing 99% of the heartbeat check from the client to server. That rather it's a server to client. So server knows whenever it's getting a message. So whenever it gets a message for a particular client, so server will push that notification to client, not other way around, right? So that's how the push notification mechanism helps a lot when it comes to the user offline, comparing to the pull. So pull is not at all recommended for this kind of use cases, right? Always, we use the push notifications, right? So this is the way we can really, it can be handled to, handle them. It can be handled to push the any new message to the receiver's device, right? This is the complete system we can build for any messaging system with a higher scale, right? So any number of users is getting added to the system, so it can really scale easily. So now the most important thing is the capacity planning, right? So when we are trying to build a system, and we build a system, we have to also estimate, like, okay, how much resource it will really need per day, per second, or maybe for this year, maybe for a future 5 years or 10 years of the down the line, right? So that has to come through the capacity estimation, right? We have to go through this phase because this is more important to visualize and probably estimate the whole maybe resource. It also directly, indirectly impacts the cost for that particular system you are designing in the long run. For the capacity planning and estimation, in very really, it's a very specific module also, how to really get into the capacity planning and estimation for any kind of system design, not specific to a chart system, but it can be any system, right? We have a video available in the channel, so it talks about what exactly the capacity planning is, how can we really remember the small figures, and we can really calculate that on the go. So capacity planning is not estimation, it's estimation, right? We can say it's a guesstimation, right? It's not exactly the number we are planning to put it here, but it will give you a overall idea, like how much cost it will be down the line, or how much resources is required, right? I'd suggest go through that other video and go through the details, like how you can plan plan the capacity for any of the system design. So at this point, we'll specifically talk about the estimation for the any messaging service. So for the any capacity planning, we can go through 3 different areas. So one is the traffic to the system, and what is the bandwidth required, right? And what is the storage required. Storage, it can be a memory and it can be a disk. So it can be, because for storage, you are storing the data in memory, right? We can talk about the cache, right? So how much memory you need to caching the data, and how much disk space we need to store this kind of data, right? So those are the things we need to plan it. So when we're talking about that, keep in mind, like this is our goal, right? To at least support this much load, right? So when we're talking about 1 billion active user, let's talk about 2 billion total user. So for 2 billion total user, we need the contacts, store the contacts details, and also for the active users, right? For active users, so if there is active user, that means they used to send receive message every day, right? So that is 1 billion. We'll talk about traffic, 1 billion billion users. So 1 billion users per day, that means there are total message it's coming to the system is 10 billion, right? So that means we can say like this is 10 billion per day. So that means how can we calculate this per second, right? So 10 billion divided by 86,400, that means in a day there are 86,400 seconds, right? So if you divide by this, so it will somewhere come around 11.5k, or it's near about 12k. We'll rounding it, so it will be 12k messages per second. Okay, so that will the traffic going to come to the system per second, right? So if, let's for example, the message size is 200 byte. So every message will have 200 bytes, right? So the 200 bytes, that means what is the bandwidth it will require? So 12k, right? So it's 12,000 messages, that is, and so it will be into 200 kb. This much bytes per second the bandwidth will require. So then if you divide by, so it will be somewhere around so it will require 12 GB of 12 GB of bandwidth to deal with the 1200 messages per second, right? But so it will come around 2.5 MB of bandwidth it will require to deal with the 1200 messages per second, right? 12k, not 1200, 12k messages per second, right? This will bandwidth. Then how much storage it will require? The storage it will require is 10 billion, right? So it's 10 billion into 200 bytes, so it will be somewhere around 2 terabyte of data. So what it will require, so every day it will need to store 10 billion messages with 200 bytes of message each message. So it will need 2 terabytes of 2 terabyte of storage to every day, okay, per day. So that means maybe 2 terabytes of data has to be also stored into the memory, right? So that means in the memory it need 2 terabytes of data to store it, right? So not 2 terabytes of 2 terabytes a day, but when we are talking about this is the storage required, right? So when we are talking about the memory, we usually go with the 2575, right? So 2575, that means if we have a 100% of the storage required for 2 TB, so 2 TB 25% of 2 TB is 0.5 TB, okay? So 0.5 TB is required to memory space required required every day to deal with the 10 billion of messages, right? So we are not storing all the data into the memory, rather just 25% of the actual data. So that means every day we need 2 terabytes of data, but this is only message, right? So we might include this the contacts and the we already send the message, but we need to think of this this particular status table, right? So status table might be this is the one 4 byte, this is maybe this is 32 byte, and this is timestamp 8 byte, and this is true false 1 byte, okay? So it can be, see, like timestamp it can be 8 byte, 8 1 10 11 64, 11 plus 64, right? So it's a 75. So 75 bytes required for every time. So that means we have to add 200 plus 75, right? 75 bytes. That means moreover it will be 300 bytes. That means 10 billion and 300 bytes. That means it will come around 3 terabyte every day, right? That means 3 terabyte out of these, it will come somewhere around 0.6 TB every day for the caching the memory. So this is all about the capacity planning as well. Probably this will need every day when we are calculating the storage required for next 10 years. So how we can calculate is 3 TB into 365 into 10. So that is the total amount, storage space we need for the next 10 years if it will go with the same number of users dealing with the system. So yeah, this is all. And thank you so much for watching the video. Please like, share and comment whatever you think, like how you could design this system when it comes to designing a messaging system, and that would be great. And also please, if you haven't done yet, please subscribe the channel. Thank you so much. Have a great one.